Hi, everyone. Thank you so much for being here today. We are very excited to answer your questions. I'm Molly Bloom. I'm the host of Brains On. We have two excellent guests here today to help answer all of your questions about the pediatric COVID vaccine. We have Dr. Katherine Wu, also goes by Katie. She is a science reporter for The Atlantic. She's been a guest on Brains On. And we also have Dr. Azza Gadir, immunologist by training. She knows a lot about the immune system. She's worked on autoimmunity, food allergies, cancer, the microbiome. She was in academia and now she works in industry. We are so happy to have them here. Hello. Thank you for being here.
Hi. Hello, great to be here.
So we have gathered some questions from the Brains On audience already. People who are here live, if you have questions, please feel free to drop them into the Q&A and we'll get to as many of them as we can. This is also being recorded, so if you want to share this with people after and let them know if they're having questions, we have answers. So we're going to start off with the basics. It's a question we got from Hetal in Colorado, and we'll start with you, Katie. The question is, why are there two names, the COVID-19 and coronavirus? What are these two different things?
Yeah, I'm so glad you asked this because this is still a point of slight confusion almost 2 years into this pandemic. So important to keep in mind, we have a name for the virus, and then we have a name for the disease that the virus can cause sometimes when it infects people. So the virus is also known as the coronavirus colloquially, but it has this very annoying fancy name, SARS-CoV-2. And when that infects people, if it causes symptoms, then that can be the disease COVID-19. So some people use COVID-19 really colloquially to apply to a bunch of things, but if we're being super, super specific, it's the virus that tests are looking for, it's the virus that spreads and infects people, but COVID is the disease that occurs in a subset of SARS-CoV-2 infections.
Got it. And how about for you, Azza? How is the coronavirus so dangerous? Like, why does it infect people and how does it make them sick?
Yeah. So there are a few things here. The first is that this virus, when it was first identified in December 2019, had never been seen in humans before. And so there was absolutely no one who at the time was immune to it, right? And it also spreads very easily from person to person, and it infects the upper respiratory system. So that means that coughing can transmit it really easily. Also, the thing about it that makes it a little bit tricky is the fact that people who catch it can unknowingly spread it before they start to develop symptoms. That was one of the things at the beginning of this pandemic that caused concern, is that asymptomatic window at the beginning where people don't know that they're sick and they're living their lives. But I think the main thing here is that the virus itself, the science is still coming out, just given that it is so new. But there are a few things that we do know about it, which is in the people that don't do so well, we know that what can happen is that they get this inflammation in the airway that can drop down into the lung, and that can cause things like pneumonia and complications in people that are hospitalized. And that obviously really complicates the picture. And that can cause damage to the lungs and can cause a whole other kind of bunch of symptoms, can impact the kidneys. There are so many organs that can be involved. And I think that like the other piece to it that has, really complicated things also with this virus is that you can catch it. It can be unpredictable. And the main kind of thing that's concerning is that people can catch it and be asymptomatic, not have any symptoms, but can then go on to develop things like long COVID, which is essentially that even after you clear the virus, you can still have symptoms for months and months afterwards. And that's something that we don't typically see with a lot of, viruses that we encounter. And so like, while, the survival rate might be high, it's in a substantial number of people, it's actually impacting them long term. So all of these things, the unpredictability of it are the reasons why the virus itself has been so concerning. In terms of the specifics as to why in particular it is so deadly, the science is still coming out on that, but we do have some level of an idea, for example, that this virus does seem to be a little bit stickier in terms of how it's infecting the cells, and all of that data is still coming out. Katherine, I don't know if there's, Katie, I don't know if there's anything else that you'd add to
No, I
that.
think that's a great summary.
Yeah, so let's move to a question we just got from Casey. So, because we're talking about the vaccine today, because now it's newly available for kids. How does the vaccine teach your body to fight the virus? Katie, do you want to take that one?
Sure. I think we can definitely tag team this one. So I often describe vaccines as, little lessons for the body. You can think of immune cells as students in a classroom, and the vaccine is there to teach them about the virus. So in this case, the lesson is about the coronavirus, and the goal is to teach them how to fight the virus without actually exposing anybody to the virus itself. So it's like the immunological version of having your cake and eating it too. You get all the right lessons, but you don't have to take any of the risks of getting the actual disease, COVID-19. So basically, when we're talking about Pfizer's pediatric vaccine, it's this small dose. It contains genetic instructions that will tell human cells to make a protein that is basically a virus protein. The virus protein will not do any harm to you because it's just kind of like showing the immune system a mugshot of a criminal's face, or like flashing a flashcard, not the actual virus. But immune cells will recognize that protein and be like, hey, that doesn't look so great. Maybe we should make a bunch of ourselves, learn how to fight it, study that protein for a long period of time. The vaccine eventually goes away, does nothing permanent to the body except prepare those immune cells to fight again. And then if the actual virus shows up, those immune cells will be like, hey, I have totally seen this before. We were really annoyed by this previously. Let's get rid of this a lot faster this time so it doesn't bother us at all.
Anything you want to add, Azza?
Yeah, I'd love to add one thing here, which is that in general, when it comes to infectious diseases or viruses like this one, the immune system itself, it has these two layers, right? And I'll try not to rabbit on too much because I could talk about this all day. But essentially, we have all of these openings in our body, right? And things are constantly coming in and bombarding our immune systems. And so you have the first layer of the immune system, which is your innate immune cells. And these are kind of like patrolmen that are just patrolling around, and their job is to say, this thing shouldn't be in the body, or this thing is okay, it can pass through. And it's actually very effective because the majority of us don't get sick majority of the time, right? But on occasion, what happens is that that level of the immune system will encounter something like SARS-CoV-2, which will overwhelm it. So it sees it, it's fighting it, punching it, throwing punches. It's realizing that it has a real contender on its hands. It's recruiting more friends. It's saying like, let's get this thing out. It's trying its best. And then at one point it realizes, actually, we're way too overwhelmed. And so what happens is that that layer of the immune system will grab a chunk of that offender and it'll run to your B cells and your T cells, which are like the bad boys of the immune system. And it'll say, guys, this thing is in the body and we can't get it out, start training. And then your B cells and your T cells start making more of themselves that are specific to the thing that they're seeing. And after a few days, those cells are dispatched, they go out to the scene, and your T cells will take out any cell that's infected, and your B cells will make antibodies that will glom onto any bits of the virus that's outside of the cell so that it can make it more recognizable and clear it. So the reason why I wanted to describe that is that that is an ideal situation, because what happens is then you have those specific responses and they stay in your system. And if you ever were to encounter that thing again, those responses would rush out to protect you. But the problem is that natural exposure to the virus, like when you're being exposed to the virus, it's far too unpredictable. You can't control the situation that you're exposed in, how much you're exposed to, how much of those memory immune responses are being activated. And so what we have in the vaccine is just one protein from the virus itself that's being shown to your immune system. So it's just the spike protein, as opposed to the virus that has 28 other proteins in it. And when you're injected with it, as Katie described, you then, that exposure to your immune system means that you generate those spike-specific T cells, those spike-specific B cells, and they stay in your system, and they're ready to protect you if you're exposed. And we have doses in the virus, even in the kids that have been standardized in the trial. So we know that these are doses that activate the memory responses we want to see. And so the way to think about a vaccine is it's not like it's not changing your immune system. It's actually working with your immune system. It's showing it something so it can go and do its thing that it's actually used to doing, as long as you're alive. And so this is something that's working with your immune system. It's just helping you generate those responses. And then the vaccine disappears. So that mRNA that you're exposed to, or that spike protein, goes away. And all you're left with is a head start and those memory responses that can help. So
excellent. So here's a related question to that from Newcastle, Washington. Jess wants to know, if children are being given a smaller dose, like we said, why is it still being administered in 2 shots? Why can't you just give them it all at one time?
So I think there's kind of two questions tucked into there. One is, what is the amount of vaccine dose affecting, and what is the number of doses infecting? So both of those are very purposeful. First and foremost, I'll kind of address why there are 2 doses. I think exactly as Azza and I have just been talking about, we are preparing the body in advance so that it is completely ready to fight off the virus should it try to infect you. This again goes back to the sort of students preparing for an exam analogy. An unvaccinated person meeting the virus is like springing a pop quiz on a student who has not studied at all. The vaccine is all those review sessions in advance that make you ready for a final exam. And so think of those 2 doses as like additional review sessions. This is a reminder for the body. One dose might be like, oh, we're kind of bothering you with this information. It may not be enough to get immune cells to take the information seriously, to lock those memories away. The second one can really clinch that learning process, increase the strength of the response, increase the quality of the response, and also increase the durability of how long the immune system stores those memories. So you're really hitting kind of those 3 points. All that can still happen with a smaller dose. And I'll point out here that kids are given smaller doses, not really just because they're smaller people, but actually because kids' immune systems are feistier. They're more responsive. Just like kids' brains are super sharp and they can learn things super quickly, their immune systems can too. They can do a lot more with less vaccine. And so parents should definitely not worry, like, why is it that my 5-year-old is getting the same dose as an 11-year-old? Shouldn't it be better if they got a bigger dose? Pfizer actually picked the lowest dose that would pump out like a stellar immune response while still minimizing side effects. So this is a really idealized dose for these kids. And it's great to give it in 2 separated bursts so that the immune system gets that really nice reminder.
And Azza, a lot of vaccines have more than 1 dose. Is that right?
Yep. So it's pretty typical, actually. So when it was the beginning of the pandemic and a lot of these companies were working out like how many doses to have. That's why, I mean, Pfizer and Moderna are very separate to each other. I mean, they're different companies, came up with a 2-dose system. It's because we've always known that 2 doses is ideal, as Katie explained, and also that usually the minimum amount of time is 3 weeks. So that's why both of them picked around 3 or 4 weeks. And so these were things that were, selected based on previous data we had on vaccine schedules generally.
So I'm going to stay on this topic before we move to some more safety questions. But, so we're talking about the dosing and when you're considered like fully trained to fight the virus. Maisie, age 8, wants to know, she said, I have 1 shot. How safe is it to be around relatives during the holidays that are not vaccinated, especially indoors without a mask? And that's also connected to another question we just got, which is how long after that first shot is there a response in kids? Do you want to start, Katie?
Yeah, sure. I can start this one off. So first off, huge congrats on getting your first vaccine dose. That's so exciting. You're in such a better position to deal with this virus if it comes around you from now on. So, thinking about the reason that we space these doses out and the reason that it takes 2 weeks after your second dose to be considered fully vaccinated, that's because, the immune system is learning over time. The cells have to kind of sit with that information, internalize it, sharpen their skills, and really develop more sophisticated responses. So that's why you're not instantly immune the second a shot goes into your body. So, what does that mean for being partially vaccinated, for being maybe a week or 2 out from your first shot? That puts you in a pretty good position, right? Your immune system has gotten its first lesson on the virus. It is steadily learning about that shot. The second one is actually going to be identical to the first one, but it is going to really improve upon, again, the quality of the immune response, the sort of magnitude of the immune response, how big the immune response is, and also, how long that immune response lasts in the body and how long your body remembers that virus. There are studies that have shown that, after you get just 1 dose of these 2-dose vaccines, it kind of like reduces your chances of getting sick by, 30 to 50 to 60%, sort of depending on the timing and who you are and a bunch of other factors. But really having that second shot, that skyrockets that percentage all the way up into the 90s. And so it makes a huge difference. So, you would be safer having a more typical Thanksgiving than you would have been last year when no one was vaccinated. But right now, a lot of public health officials are saying, if you really can wait to celebrate, the winter holidays are right around the corner. It will be safer to interact with other people, especially indoors, especially unmasked, if you are fully vaccinated when you do it rather than partially vaccinated.
Anything you want to add, Azza?
No, well said.
Okay. So let's pivot to talking a little bit about some of the safety concerns people have. Let's start with the trial. So we have a couple questions here about how many kids the vaccine was tested in and what the results showed. Do you want to start, Azza?
Sure. So a few things here, right? So I can start by just going through the very quick kind of basics, which is in the kids trial, they actually had about 4,753 participants in the trial. That is actually quite typical. I know that that's been concerning for a few people because they're like, that number seems low, but there's a few things here that are really important, which is typically with the clinical trial process, you start with people that are older and you move backwards. And that's just because we protect children, right? So they're usually the last group that we'll test any intervention on. But in general, we have at this point millions of people worldwide that have had the vaccine, millions of adults, right? And so that's a lot of data. And the first adults to get the COVID vaccines, particularly the mRNA, were in March 2020. So in the phase 1 trials of last year, and we're tracking them still, and we're more than a year and a half out. So we haven't seen anything unusual in terms of, we know what these vaccines are doing. They're mimicking infectious disease. We're seeing those memory responses activated. And so we have all of that data from millions of people worldwide. We also have data from the 12 plus ages, and we can see as we're moving down into lower age groups, again, we're seeing exactly what we would expect, which is activation of those responses. To Katie's point, we know that kids in general do really well with infectious disease. And so it's not a huge concern in terms of we're expecting them to behave completely differently. In fact, your T cells that I mentioned earlier do get weaker with age. And so we know that kids have really excellent responses. And we've seen that in the trial. But so usually by the time we get to those younger children, these are pretty typical numbers that we're looking at. And something that's really important to note is that we have never in history had an adverse event present more than 6 weeks after administration of a shot. And it's very easy to understand this because if you're going to have an allergic reaction, for example, that's going to be that innate immune layer. That's going to be immediate, and it's going to happen within the first 72 hours. And then if you're going to get any of the really rare events that are noted with other vaccines, so things like idiopathic thrombocytopenia or Guillain-Barré, for example, these are things that are driven by your adaptive immune response. And so you start to see those symptoms around day 5 to day 7 when you activate the adaptive immune response. And then when you peak antibodies, that's around week 3. So it's typically in that window that you get symptoms. And so given that in history, again, after a shot, we've never seen an adverse event more than 6 weeks after, the FDA has their cutoff at 8 weeks. That's why the trials are about 8 weeks long. At this point anyway, we're way over that window in the adults, right? And so these are some of the reasons why we're not concerned. And vaccines are not like treatments, for example, where, for example, if you have diabetes, you give somebody insulin in order to fool the body into thinking it's making its own. And you take those medications over time, right? So you have to note things like toxicity, build up in the system, what that means for people. But with vaccines, because you're mimicking natural infection, you're just, that's why we understand the mechanism really, really well. And so that's why we don't have concerns about long-term symptoms. So I'll stop there because I can rabbit on about other concerns about fertility and whatever, but I think they're coming.
Yes, we'll kind of get to that. Yeah. Did you want to add anything, Katie, before the next question?
The one thing I will really quickly add, I think one other difference to point out here is that we do have to remember that these vaccines are not sticking around in our body. It's not like they're altering the composition of our cells. They're influencing immune cells, they're teaching them, but it's not like they're completely rejiggering the immune system or leaving a permanent mark on the body. So whereas you can have long-term complications from something like an infection where there's an active infectious agent that's copying itself in the body, maybe even lingering long-term in some unusual cases, that's not the case with the vaccine. So we're really thinking about how the body reacts to the vaccine, exactly as Azza just described. Those timings for adverse events really match up with when the immune system sort of kicks into gear in those two waves, and why we wouldn't expect anything beyond that, because there's nothing to really trigger it beyond that timeline.
Excellent. So there's a question sort of about mRNA vaccines and how those might be different than conventional vaccines that have been around, in that we've all had when we were little. So the question is, the mRNA vaccines have been studied for a while. What do we know about the early trials of mRNA vaccines? Were there any long-standing problems after those? Azza or Katie?
Yes. Yeah, I'm happy to get it started because mRNA is just so cool. So the main thing here is that mRNA is every time any cell in your body needs a protein, in the nucleus of the cell, it'll send this mRNA, which is essentially like a recipe, to these 3D printers that you have sitting outside of your cell, like outside of the nucleus. And these little 3D printers are called ribosomes, and their job all day, every day, is to take these recipes, read them. They already have the ingredients inside them, and then they make and shape the protein, because your immune system doesn't see lines of code, it sees shape, right? So the ribosomes are important for shaping these proteins. And so this is a process, again, that happens in our cells like majillions of times a day. Like these ribosomes are reading, they're shaping, they're making the protein. We've always known that if we could harness that it would be excellent. It would be safe, because mRNA is incredibly unstable. It doesn't last very long. It's read and then it pretty much is, disintegrated by the cell or degraded. And so we've had this technology in the works for about 3 decades now. Originally, so in 2011 was the earliest that we actually put this technology in humans, and it was in cancer. And the reason why it was put in cancer is because when you have a new technology that you want to test, when you go to a regulatory body like the FDA, they won't allow you to just test it on any disease, right? Because you can't just go around testing it on any person. Typically, companies will start with diseases like cancer that have really poor other standards of care, where the patients are so desperate to a degree where like you really want to try as much as you can. And so that's why with this technology, we have data dating back to 2011, where we've seen it tested in cancer patients. Those were more than 10 years out at this point, and we know that the technology wasn't doing anything out of the norm. When it came to viral infections or approving it for a vaccine, we kind of needed a pandemic at the scale in order to be able to recruit this many people into the trials, to be able to really like test it out and to get the clinical trials completed. And so I say all of that to say that the way that the technology is working is again, like our other traditional methods of vaccines that we've used in the past, and things that J&J and AstraZeneca use. They actually use a way of injecting the DNA for the spike protein itself into the cell. It doesn't integrate with your human DNA, but it does go into the nucleus, essentially borrows tools in order to make messenger RNA that's then released and goes to the ribosome. The mRNA vaccines are just shortcutting that process and going directly to the ribosome. And so the expectation here, we understand the mechanism. We haven't seen anything unusual more than what we would expect in cancer. Theoretically, it's way safer. The cell is degrading the mRNA immediately. It's not lingering around. And so that's why we don't have concerns about the long-term effects of this technology.
Excellent. Katie, anything you want to add?
Yeah, that's really well said. And I think the only thing that I thought of during that to add is that, for anyone who is concerned about, mRNA could still be an unusual thing to be putting in the body via vaccine. Researchers have really, really paid attention to this. They've even like slightly modified the mRNA that's going into these vaccines to make sure it's packaged in a really careful way. It's not going to rile up our cells too much, but it's still going to do exactly what they've instructed them to do. They tested this in animals. They also trialed a rabies mRNA vaccine several years ago and saw that, it looked really great. Like this has really been technology that has been put through the ringer. And it's sort of just an iteration on a very common motif in vaccinology already.
So just to reiterate for people who are concerned about sort of that mRNA technology hasn't been around as long and they're worried about long-term effects, what we're saying is that this mRNA technology actually has been studied for a long time. It's been used in humans for 10 plus years, and long-term effects are not going to happen because the mRNA does not stick around in your body. And if you were going to see adverse effects from the vaccine, it would happen within 6 weeks from getting the vaccine. So we feel confident that there's not going to be someone you discover like 10 years later.
And actually, one other thing that I would add is that when it comes to viruses themselves, they do hijack the cell, right? They infect a cell and then they'll hijack a cell to make more of themselves, and then the cell bursts and they go and infect other cells. I mentioned that to say that actually the virus itself hijacks ribosomes to get it to force them to like make more like the proteins that they have. And so this is actually just like a way more like honed in. Like if you really want to look at for me, for example, the virus itself with its 29 proteins that are all hijacking cells and are all dabbling with ribosomes and doing all, is just theoretically way more of a risk than this one pathway that we have tested for like over a decade and we understand so well. So like to compare it to the virus itself, that's the way to kind of look at it too.
Right, because viruses can have long-term effects on your body in a way that the vaccine cannot.
Absolutely. I mean,
Cool. So let's ask another question that we've heard about safety from a parent who's concerned that the vaccine will have an impact on future fertility. Hearing about heavy periods as a result of the vaccine, worry their daughter will go into puberty early. So let's start there. Do we know if there's any effect on future fertility or puberty?
So at this point, there is zero evidence that this vaccine or any other that I'm aware of is going to have an impact on fertility, apart from keeping you alive longer so that you can eventually reproduce. If you so choose. That is the biggest impact on fertility that I personally see. I know there were huge questions going around about this and some misinformation early on, even as far back as, the adult trials. People were saying, oh, it's going to negatively impact fertility in women. And then there were concerns about, people who are non-binary or men. This misinformation goes back quite a ways, and it now seems to have trickled down into the pediatric populations. But there is no biological basis for that. I won't repeat the misinformation that was going around because none of it is true, but truly we would have noticed by now. We really, really, really would have. There have been so many people who have been trying to conceive children, who have successfully conceived children after receiving these vaccines. There have been pregnant people who have received the vaccine during pregnancy and delivered very healthy, happy children. We would have noticed a signal by now. There is just no basis for thinking that there would be an impact on fertility. And, I'll address that, yes, there have been people who have reported my menstrual cycle was a little weird after I got the vaccine. That can totally happen. And those concerns should not be dismissed or ignored. I know there are scientists actively looking into that, but just because they are actively looking into it does not mean there is a long-term concern about fertility. It's worthy of study. People's concerns should be heard, but I don't want people to over extrapolate from that. And I think the important thing to keep in mind here is that for anyone who has had a menstrual cycle, you probably know that they can be a little fickle. When you get stressed, when you get sick, things can get a little wonky. You might bleed a little longer, you might bleed a little spottier. Things happen, but very often they revert back to normal. And a lot of the people that have been reporting these changes to their menstrual cycles, they follow up weeks later and they tell the researchers, hey, I'm totally back to normal. Seems to have been temporary, and think your body just kind of went through a boot camp learning about this virus. That might have been a little taxing for it. Think of how athletes' menstrual cycles sometimes change when they train really hard. This is not exactly the same thing, but there's something maybe equivalent going on. When we ask a lot of the body, sometimes it can switch around where it diverts its resources.
Absolutely. And I just want to say that the most powerful data at this point is that we have data from IVF clinics that have looked at looked at people trying to conceive before and after the vaccine, and zero impact to hormone levels, egg quality, fertilization, pregnancy rate. So even the menstruation, it's not the same mechanism. And by the way, the endometrial lining has immune cells in it. So it's not surprising that if you have an inflammation going on that you'd pick up signals. But again, to Katie's point, menstrual changes with the vaccine is something that's been noted with the flu shot as well. But it's something that anecdotally, but it's something that we know doesn't impact fertility, which is why we maybe didn't really probe into why exactly it was happening. We knew it was transient, it wasn't long-term, but there's just no data to support any concerns in terms of the fertility question at this point.
Here's another question that came in through the chat, wondering, why if kids are really, not getting as sick, they don't seem as vulnerable to disease, why should they get the vaccine?
Yeah, and this is a really important question. I think the way that I have approached this is to think about the fact that we have this incredible tool and we can be preventing the diseases, the symptoms that do occur in children. Yes, they are less common than adults, but just because something is less common does not mean it is totally rare, does not mean it is of little concern. There have been millions of kids who have caught this virus in this country alone since the pandemic started. That is not negligible. And we know that the very small percentage of those kids go on to be hospitalized, and even smaller percentage go on to die. And that has been really, really, really wonderful. But that is not negligible. That is still hundreds of kids. That is still thousands of kids that have gone on to experience really, really bad outcomes. And hospitalization and death are not the only outcomes you want to avoid. We know that kids can get long COVID. We know that kids can get severe respiratory disease. We know they can get this rare but pretty severe inflammatory syndrome called MIS-C. And for a lot of these conditions, we know some of the things that might predispose kids to some of them, like, being overweight, having diabetes, maybe having asthma. But for some of them, we don't. We know nothing. We don't know when COVID is going to enter a kid's life or a kid's family's life. And having this vaccine means that all of those things that I just listed are now vaccine preventable. Giving a vaccine means that we can prepare kids ahead of time, knowing that there is this looming risk out there while this pandemic is still going on, while this virus is still spreading around. And the risk benefit analyses that have been done over and over by experts at independent research institutions, as well as at the FDA and the CDC, time and time again have shown that the benefits of getting vaccinated right now far, far, far outweigh the risks. I know there are some questions about unknown risks and some question marks, but we know that COVID and the virus that causes it, SARS-CoV-2, those are known risks. We know those are very, very bad for kids to get, and they can really be bad. And so when weighing a big known risk against the possibility of some smaller unknown ones, it really seems like every single time the kids should be getting the vaccine.
And I also don't want to panic anyone, but the other piece to this as well is that a lot of the neurological symptoms, for example, that adults are reporting as part of long COVID are things that young children can't articulate, which is also a concern. So adults will say things like, I feel foggy today, like I can't concentrate. And I've noticed I feel depressed, whereas a 4-year-old might not be, they can't say to you, I can't read today, or, so that's the concern that a lot of pediatricians have as well, is that we might not actually know the impact until these children are old enough to articulate. And so that's why it's better to just give them that snapshot, give them those immune memory cells, and then have them in their system, and it can offer them a level of protection if they're exposed.
That's great. So let's talk a little bit about, what happens with the virus after you've been vaccinated. Questions about breakthrough infections. Someone in the chat wants to know, do we know what the rate of breakthrough rates is versus reinfection?
Yeah, this is a great question, and it's a little bit difficult to give a completely firm answer because we are not systematically testing every single person in this country on a regular basis. And we know that, as we discussed earlier, that asymptomatic infections can happen. Those also technically count as breakthrough infections. But, for some perspective here, even if a virus can infect you after someone has been vaccinated, that does not mean the vaccine failed. It is not the end of the world. There's this enormous spectrum of what can happen when this virus infects someone, and what vaccines are doing to an extraordinary degree is sort of decoupling infections from severe disease. Even if people are getting infected, they're not getting infected as severely or for as long or as contagiously. And that is a huge, huge deal. That said, some of these infections are still occurring. it seems to still be relatively uncommon. That doesn't mean like only a couple a day, but in percentage wise, it is still relatively uncommon. And that is really important to keep in mind. The few studies we do have of, how protective it is to have infection-induced immunity versus vaccine-induced immunity, there are some mixed results, but I will point to one recent CDC study that showed that, people who were vaccinated were less likely to get infected by the virus after acquiring immunity that way. And that is really, really convincing to me. As I also pointed out earlier, that you really don't know what's going to happen when you get like infected. It's such a variable experience. There is no guarantee that you will not get super, super, super sick. And there is no guarantee that there will be lasting immunity left behind. That can happen, but it's not a guarantee. A vaccine, on the other hand, is something that we know to be safe, something that we know to be consistent, and we know to be effective.
Actually, I'd love to add like one analogy that like it might help, and it's not mine. It's something I'm borrowing off someone. I can't remember who it was, but it's the sandbag analogy, which is if you knew that a hurricane was coming to hit your house, you would put sandbags outside, right, in order to protect your house from the flooding. But if the hurricane is intense enough, you might still get trickling through that sandbag, right? And so that's the way to kind of think about a vaccine, is that it gives you a layer of protection. It can give you a head start, but it is possible for breakthroughs to happen, and the sandbag analogy might help people kind of think about why that might be.
And here's another question about this. So once kids are vaccinated, are they still able to spread the virus? I guess this goes for adults as well.
Yeah, the data on this is still very much being collected and still evolving. It does seem like, transmission after vaccination is possible, but again, it is less common than what happens in an unvaccinated person. The way to think about this is, I think coming back to these great analogies about sandbags, or, another one might be umbrellas or sunscreen. The vaccine is not erecting like an impenetrable force field around you. I think one way to think about this is, if you are going to go out into a light drizzle with an umbrella, maybe you'll just stay totally dry. But if you walk into a hurricane, you're probably going to get a little wet. Like, it depends a little bit on the conditions around you. The vaccine will offer, some sort of constant protection. But we know that if conditions are bad enough, or people's behavior is risky enough, we're sort of challenging the vaccine to something far greater. A more like robust and frequent attack is eventually going to overwhelm any barricade. And so, that will increase risks of infection, and then maybe like a trickle effect will affect symptoms and then transmission. So those things are possible, but they depend both on being vaccinated, which is going to reduce the risk of transmission, but also the behaviors we take to sort of set up our vaccines for success. Again, the data is still being collected, but it really does look like transmission is down among the vaccinated. And the more people are vaccinated, because remember, this is like a communal risk, we pass the virus between people, the more people are vaccinated, and that's going to definitely include kids, the less transmission is going to occur, period.
Azza, anything you want to add?
No, well said.
Great. We have time for a few more questions. So here's a question from Brother Age 9. As soon as you get your COVID vaccine, can you stop wearing a mask immediately? Azza, do you want to take that?
Yeah, so I was going to say that this is kind of circumstantial, right? It's mainly because the pandemic can still continuing to rage in so many parts of the world, and in so many parts of the US as well, right? So while the risk of infection is still so imminent, and we have, so like it's still continuing, the pandemic, it's not over. That's why the best thing that we can do is to make sure that we employ as many methods as possible. Just relying on one thing, I mean, if there's something we've learned from this pandemic, that never works, right? If you just rely on vaccinations or just rely on mask wearing, it's not, you need a combination of factors. You need to factor in things like social distancing, ventilation. Like, the more of these layers you can put into place, the more likely you are protecting yourself and your community. And so right now, given just where we are in the pandemic, it is important to continue wearing a mask, just so that it just offers another layer of protection. Hopefully we will get to the stage where this pandemic will dwindle, and the vaccines have really helped us here in terms of offering protection, where we will be able to take masks off at one point. I mean, if you look back in, I know it was a different circumstance, but if you look back in at New Zealand or Australia last year, at one point the numbers were so low that they took their masks off, right? And they were fine, but then obviously numbers came back up again. And so we just need to continue wearing masks. We need the layer of vaccination, and that just needs to continue. And all of these precautions are something that we should all factor in just until we can see this pandemic kind of really slow down and numbers really, really come down.
Yeah,
the one thing I'll add
yeah.
super quickly there, if there is any question about, I just got my injection 2 minutes ago, can I take my mask off now? I'd wait. I'd wait just a little bit. And, for if it sounds like it was a 9-year-old who asked that question, something that might be helpful to think about is you cannot eat cookies the second after they go into the oven. They have to bake a little bit, and then you have to wait for them to cool. There is a bit of a waiting time, but I promise it's worth it.
That's great advice. Here's a question that just came in through the chat. Doesn't a universal vaccine cause variants?
Ooh, this is a very good question. And I'm going to preempt this by saying the answer is no, 100% no. Think about what a vaccine does, right? A vaccine is going to train bodies to be better prepared to fight off a virus. People are going to be infected for less time. They're going to carry the virus less around. They are basically making people less hospitable environments for the virus to copy themselves and do all the things that viruses want to do, which is replicate and spread, make more of themselves and get into new people. If a virus isn't able to do that, it's not going to be able to do much of anything. For new variants to arise, viruses need tons of opportunities to copy themselves over and over and over and over and over and over and over, so many times that they start to make mistakes when they copy themselves, that they start to mutate, right, and create new versions of themselves that might be better equipped to spread between people or bypass immune cells. If they're starved of those opportunities, if they can't even play around in your body and have those opportunities to make those mistakes and make more of themselves, it's just not going to happen. It's stripping opportunities away from the virus. And that's a huge, huge, huge plus of getting vaccinated.
Excellent. Here is a question, Azza. What about children that have already recovered from COVID? What's the benefit of vaccine for kids who've already had COVID?
Yeah, so the thing is that COVID is just really unpredictable, right? We have data from adults. We also just have data across the board showing that there's a percentage of people that don't mount long-term immune memory responses. It's just way too unpredictable. The fact that you've got all of these other proteins involved with the virus, your immune system can make antibodies to the other proteins, right? But like you might have heard of things like the nucleocapsid protein or the envelope protein. It is possible for your immune system to make antibodies to those, but they're not necessarily neutralizing. And that is the main thing to remember, is that we're trying to achieve antibodies and T cells in general that are able to help neutralize the virus itself. And so the thing about it is that there's just no way of knowing, right? There's no way of knowing after having COVID-19 just how protected you are. And even if you take an antibody test, by the way, there is no commercial antibody test available that will tell you how many of the antibodies you have are actually what you are neutralizing, right? Some of them just are mounted and don't help your immune system clear the virus itself. And so given that unpredictability, we know that it's safe, right? We've tested safety. We know it's safe for people who've had COVID-19 before to get a vaccine. And so if anything, getting a vaccine after infection, we know gives you this hybrid immunity, which means you have really strong immune memory responses across the board. I know that I've been referencing B cells and T cells generally, but in reality, your immune system has so many different subsets of cells and so many different compartments that are involved. And we know from the immune memory data we've been generating, there are so many labs that have been taking blood from people and monitoring this stuff over time. We know that the best thing you can do, even if you've had COVID-19 before, is to get a vaccine to really optimize those memory responses.
Yeah. There's even CDC data to show that getting a vaccine, even after you have been infected in the past, it substantially cuts down on your risk of getting reinfected. So it is making a huge and measurable difference.
Excellent. We have a couple questions about underlying, conditions that someone already has. So someone was worried about their granddaughter who has had the herpes virus and that the vaccine could reactivate the virus. We also have a question about the vaccine contributing to an autoimmune disorder. So how do we answer these questions?
So I think it's really important for like specific conditions to have conversations with your doctor, just because I know that's the boring answer, but it's they know your history, they know what other medications you've taken and what your diagnosis itself actually is. But I would say that in general, the way to look at this is risk benefit, right? You're comparing getting exposure to the virus itself to getting the vaccine to give you that prevention. And so generally, I mean, what we know is that there are a lot of things that can be activated by the virus itself, and there is maybe a risk that the vaccine itself can do that. But you know, depending on the situation, we just we don't fully know. We know that the vaccine is a way safer option. We know that people that have comorbidities or people that have autoimmune disorders getting vaccinated, and these were some of the first waves of people to get vaccinated, substantially protected them from exposure to the virus itself, just given how high risk that exposure can be. And so I guess my answer to this would be, even with things like reactivation of viruses, I would speak to your doctor about it and see what your risks are. And the general expectation is if there's a risk of that happening with the vaccine, there is a much higher risk of that also happening with the virus itself. And so it depends on the situation.
And we haven't, and one question we have here is about, you know, what your body does after the second mRNA shot. Is it true that the body picks out which antibodies were most effective from the response to the first shot in order to create the strongest neutralizing antibody defense? Is it true?
I really love this question. It's like, yeah, I was like, I'm going to just jump in again. But so the thing about it is that when you get that second exposure, right? So you have the first dose and then you get that second dose. The immune system does this thing, which like for me in my head, the way that I envision it is that, you know, when you're in the fairground and you see those machines where the claw comes down and picks up a bear, right? Or picks up the toys, is that when you get that second exposure, the immune system is like, crap, why is this thing back? You know, like I've generated these memory responses. I thought I got rid of it. Why is it back? So what it does is that it kind of does this thing akin to like using that claw to dip into those memory cells and picking the best binders or the best, you know, contenders and the best warriors out of them, and then selecting those for like future, for them to be kind of the warriors you have in your system for kind of future exposure to the virus itself. So what that means is that that's why when you hear people say things like your immune system gets better at fighting the virus over time, it's because the more exposure it gets, the more actually it hones in the responses to the virus that it gets. But I'll also let Katie jump in here because it's a very cool immune phenomenon that happens.
Yeah, I mean, I think you already described it really well, but I just, you know, we have to take the opportunity to geek out whenever we can. But it's an amazing thing. It's kind of, in a way, this ruthless competition between cells who are all like, no, I want to bind the thing better. No, I want to bind the thing better. And the ones that do the best job at, you know, glomming onto this dangerous thing, those are the winners. The rest actually get selected out. They're kind of booted off the island, or whatever analogy you want to use. It's an amazing process because, you know, the body has finite resources. If it's going to keep a sort of contingent of veteran fighters around, it really wants to make sure that they're the best ones that are kept on retainer. And so it's constantly evolving itself. In the same way that the virus is always trying to, you know, evolve to be more successful, our immune cells are doing the exact same thing. And so it's kind of incredible. The cells in our immune system are unique in our body because they continue to change throughout our lifetime and improve themselves over time. It makes me, as the rest of the body, feel very lazy.
Okay, we're going to do a couple more before we wrap up. Thank you so much for your time today. So this is a question about a vaccine ingredient. It says the vaccine for kids under 12 includes tromethamine. I'm not sure if I'm saying that right, but one of the potential side effects is that this medicine may cause tissue damage if the drug leaks from the vein. Is this a concern? Do either of you know about tromethamine? I can give you a sec.
Yeah, I actually do not. So
yeah, me neither. Sorry, just trying to read the question. Yeah, I don't know anything about this. I have never heard this as a concern. But I suppose, you know, the only thing that I would say is that the vaccine is not injected into the bloodstream, if that is helpful. I don't know if that helps address.
Oh, so I actually, if it's so, sorry, I was hearing trimethamine and it's tromethamine. Sorry. So I think it's just a stabilizer that's basically being put in to stabilize the pH of the vaccines themselves. I'm not aware of like any concerns around it leaking out. I will say one thing actually, because this is something I've seen where if you look up data sheets for the individual ingredients, that you can often see a laundry list of things that can potentially be caused. But one thing that we know is that it's really important with these ingredients to know that those side effects are related to dosage. And so when you're looking at just, you know, the ingredient itself, that's just an open-ended laundry list for any dose that you could use, no matter how high it is. But in the vaccine itself, like really low dose amounts of the stabilizing ingredients are being used. These are actually inactive ingredients. They're not at dosages that are high enough to actually cause any changes in your biology, right? The only active ingredient in these vaccines are the mRNA itself, and then in some people that have allergies, the polyethylene glycol. But in general, I think that yeah, I would say, I to be completely honest, I haven't heard that before, but I would say that if that did come from a safety data sheet itself, just note that with those data sheets, they don't have dosages, so that's why they have to list everything that's possible. Even if you had a huge amount in.
That's a really, and we have a comment here echoing what you just said, Azza, that the comment about tromethamine applies to massive doses given by IV infusion to treat acidosis. So again, this is a much smaller amount than what you would get if it from an IV infusion.
This is Tris, right?
Say it again.
Is this just Tris, Azza? Yeah. Oh, sorry. I apparently did not know its proper name, which is embarrassing because I've literally used Tris hundreds of times in the lab. But yeah, I mean, and I'm sorry if you already said this, but this was a buffer basically swapped out into the pediatric formulation of the vaccine, replacing something that was in the adult vaccine. And the primary reason that it was done was to actually make the vaccine more stable at refrigerated temperatures, which is actually a really good thing. That means that pediatricians or whoever else is doling out this vaccine can open a vial, give an injection to a kid, put it back in the fridge, and it'll last longer. Tris is a benefit there. It is not something that is supposedly addressing like, oh, we are worried about something else going on with this vaccine. It's a stabilizer that happens with any formulation of any vaccine. It's just to help the vaccine do its job the best it can for as long as it can.
Great. Thank you so much. That was a complicated one. So I think we'll end with this one that came through the chat. After we vaccinate our children and transmission levels are lower, does this give us freedom to travel or participate in public activities? Can we get back to life? Who would like to take that one first?
I'm happy to start. So I think there are kind of two tiers in my answer to this question. I think the first is getting vaccinated is an enormous step to be taking in the context of this pandemic. You know, for a family, for an individual, it makes you at much lower risk of getting seriously sick. But which means, you know, your family can maybe start feeling more comfortable doing certain things. It is a big step forward to helping end this pandemic. But as we've talked about multiple times before during this conversation, vaccination works best when it's a step taken on a collective level. The more people get vaccinated, the bigger the impact it's going to have. It's almost this synergistic effect on transmission. I think for everyone who is vaccinated, for everyone who is moving toward vaccination, we can all take a huge sigh of relief. We can all feel better about the activities we're engaging in. We can feel better about coexisting with this virus, which is going to be the case for quite some time yet. But we can't fully check out of this pandemic. A vaccination cannot recuse you from what else is going on. There are still millions of people out there who are unvaccinated, billions if we expand out to the world. And as long as that is the case, the virus is going to keep circulating at high levels. People will still be at risk of getting seriously sick if they catch the virus. And I think that is really important to keep in mind. So whenever you are making decisions about, you know, do I move about more freely? Do I travel? Do I do X, Y, or Z? Think think about your risk, but also think about the people that you'll be interacting with. Are they unvaccinated? Are they vaccinated and maybe still vulnerable because of a health condition, their age, or an immunocompromising condition? Who else is in your community? Is the healthcare system locally equipped to take on cases? God forbid there should be a rise. These are really complex risk calculations to make, but I think vaccination really has to be continually reframed as something that impacts all of us, and that other people's vaccinations also impact us.
Azza, do you have anything you want to add there?
Brilliant. No.
And I guess just one last question for both of you. What would you have to say to people who are feeling hesitant or feeling like they don't have, information they need to make a decision for their kids, whether or not to get the vaccine? Where would you point them to get more information?
So actually I just wanted to say like a few things, because I do think that we're all exhausted. This pandemic has been rough on everybody, and it's a lot of information. And so like, it's normal to have like a little, anxiety around making this decision or making any decision in regards to this pandemic. A few things that I would want to add is that in general, number one is that science is a consensus, right? It's never just one person who runs one experiment and we change everything based on that. It's basically multiple groups will like publish data or will like publish results from different trials. And then that is what's taken in all together. And that's why when people say things like check the CDC website, check this, it's not that we're saying, the science is never going to change. It's that people are saying this is the current consensus based on what all of these groups worldwide or like all of this data that we have so far is. And so I mentioned that to say that like a few people will say, well, there's this one doctor who's not saying that, but that's why science is a consensus. We don't listen to just one person who has a contrarian opinion. They need to present data and have it be peer reviewed for that data to be factored in and making a decision. The second thing so I guess I inadvertently said that like, look to, the CDC website, that updates regularly with like the consensus as the data is coming out. The second thing I wanted to add actually is we all have to be a little bit better at like asking people what their sources are. And I actually want to say that like, if there's anything I've mentioned today that someone wants a source for, please DM me on Twitter or whatever, and I'm happy to provide it. I think that in general, again, people have anxiety and just getting some information, like, earlier there was the fertility question, like asking people, where is that coming from? Can you just point me to where you got that information from? Simple things like Googling the people in the article. Do they have experience to be, talking about what they're speaking about? What's their past history? Things like this can just make us all a bit better at recognizing like misinformation as it comes out and knowing what's something that's worthy of like causing concern and what's something that's actually not causing any concern in general and shouldn't. So those are just like my 2 cents.
It's great advice. How about you, Katie? Anything you want to add?
Yeah, I mean, I think this is a really good opportunity to think about who are the trusted sources of information in your life. Can you go back to them for the same sort of thing? I know pediatricians' phones are ringing off the hook and have been for weeks now, but they are all so thrilled to be answering these questions. I heard from one recently saying like, I've never seen so many kids in my office excited to be getting these shots. Normally they're being dragged there, by their toes by their parents because they don't want to get a shot, but it's like Disneyland for them. That's something that pediatricians are excited about. They're excited to answer questions. And I think, I also do want to take this opportunity to acknowledge that there will be a lot of questions. There will be a lot of questions going forward. We are operating in a time where there is imperfect information and there are some question marks that are lingering. I don't want to dismiss that, and I don't want to dismiss anyone's concerns. And so that's why I'm so glad that there are Q&As like this and elsewhere so that people can bring their concerns forward, they can be heard and they can be talked through. And importantly, that experts can acknowledge, hey, we still don't have complete information on X, Y, and Z, but you know what? It's actively being looked into, and we will let you know as soon as anything changes, as soon as we have an update. I think that has to always factor into this. That makes this a little confusing and a little more frustrating, but all of those uncertainties have been taken into account when people are doing these risk-benefit analyses. And I think time and time again, really the consensus at this point, sort of referencing what Azza was saying, if we're looking to consensus, the vaccines are safe, the vaccines are really doing an incredible job. And I am just so excited that kids at least 5 and up have this opportunity, and the younger groups are really going to be next within the next couple months.
That's awesome. Well, thank you both so much for your time. You answered the questions so well. Lots of people saying thanks in the comments here to both of you. So thank you again for your time, and thanks to everyone who came to listen today. This is going to be posted soon, so you can share it with friends who may have any questions. And you can find Dr. Katherine Wu and Dr. Azza Gadir both on Twitter. We'll post those too and send them out when we send this email out with the link to the video. And you can read Katie's excellent reporting in The Atlantic. She's talked about a lot of these issues, so very in depth. So thank you so much to both of you. Have a great day, everybody.
Thank you for having us.
Thank you.
Bye.